Hey there, as you watch this video, please do take notes as though we were taking notes in class. So this is an application problem of the vertex stuff that we've been doing in class, particularly finding about the maximum and the minimum and how that could be useful potentially to us as you use these beyond just this math class. So something that companies actually do is they make decisions on how to price their products. And so when they price their products, people buy them and they generate revenue. So there is really a big problem though, is that sometimes if they cost too much, people won't buy them, and if they're too cheap, then you lose profits that you could make. And so there's this kind of this ideal price that you want to pay for a selling price for a particular product, and you got to test that out. So one company tests different prices in a research scheme, and they find out that to make the most profits, they need to sell according to this curve. So maybe they give a discount, they make a little less money, but more people buy them. If they increase the price, fewer people buy them, but they still make a profit. So we just are going to look through this. All right, so the selling price, if we take this, we want to look for the maximum. Well, in class, we learned about the formula to find the vertex, and so we're looking for the h value, which is the x value of the vertex. We knew that that was negative b over 2a, and here, if we look, the a value is negative 10, and the b value is, 700, and there should be an x there, my mistake. And so to find the vertex, we're going to use this formula. So it's negative b, and b is 700, so negative 700, divided by 2 times a, and a here is negative 10. So this ends up being negative 700 over negative 20, which is 35, positive 35 in fact. So we know that the vertex here has an x value. The x-coordinate is 35. Now we need to decide how much do they actually make when it costs 35. And what we do, and we talked about this in class, is we're going to substitute this 35 as the x value in our function because it is the x value in this particular function. So we know that they're going to make the most money when they sell them for $35. So f of 35 is equal to negative 10 times 35 squared. 35 squared. This is the 35 that's here. 35 squared plus 700 times the 35 minus 6,000. And that's just quite a large number. So if we were to put this into a calculator, we'd have to follow the order of operations and make sure that we're doing the exponents first, but you eventually get $6,250, which is the profit that they're going to make when, I'll do this in red, is the profit they're going to make when they sell them for $35, which is the most, according to this problem, that they're going to make. They're going to make $6,250 by selling them at the sales price. The max profit sale price is $35. I know I went really quickly here, and you may want to pause and back up, but really consider where is this 35 coming from, and why does it represent the maximum selling price, and then how did I get this 6,250. We're going to do a practice problem. All right, I'm going to encourage you to pause the video and just try this. I'll go through it in just a moment, but I want you to give it a shot first. So if you think about a water balloon being thrown, and it's really starting from not on the ground, we know that this thrown from a window, the height of the balloon over time is modeled by this equation, and we're trying to look for the maximum height value. So it actually is being thrown from a height of 50 feet, which is, a 2 or 3 story building potentially. And it's being thrown up and down, and it's going to eventually hit the ground. And so another question we're going to address later is, when does it hit the ground? And we're not there yet, but we will be soon. So today we're trying to identify where the peak is. So pause the video and try this problem. We're looking for the maximum height. right? Hopefully you've gotten a chance to try to identify the maximum height here, and we're gonna go through it. So we're looking for the x value of the maximum, and we know that's the h in the equation. So we know from class that h is equal to negative b that over 2a, and we've got our a, and we've got our b, and we've got our c, but c doesn't matter in this equation, so we're gonna the x value, the h value, the x value is negative b, so negative 160 over 2 times a, which is negative 16. So that ends up being negative 160 divided by negative 32. And that is 5. So it looks like it takes it 5 seconds it looks like it takes 5 seconds here to get to its maximum, but that's not the height. We're looking for the height. We're looking for this value here, and we're not quite sure what it is. So we have to substitute the x value of the vertex back into the equation. So we've got y equals negative 16 times 5 squared plus 160 times 5 plus 50. So I've got negative 16 times 25, so negative 400, plus 160 times 5 is 800. These are turning out to be nice numbers. Plus 50, so that's 400 plus 50, so that's 450 feet. And that's the height of the water balloon at its peak. And so when we're answering the question, what's the maximum? What's the maximum height? The maximum height is 450 feet. And remember, with word problems, it kind of gets annoying, but you want to make sure that you're labeling them. I hope this video is helpful, and you can use this moving forward.